So what is the pH of waters in the North Pacific doing? Well, research reveals that waters of the North Pacific are acidifying more rapidly below the surface. Hello friends, Jim here. CO2 in the atmosphere enters the ocean at the surface and has been increasing the acidity of Pacific waters since the beginning of the Industrial Revolution over 200 years ago. Well, it's all the oceans, but anyway. A new study led by University of Hawaii at Manoa oceanographers revealed that the ocean is acidifying even more rapidly below the surface in the open waters of the North Pacific near Hawaii. Their research was published in the Journal of Geophysical Research, Oceans. Ocean acidification has far-reaching consequences for ocean biology and the global climate, said Lucy Knorr, who's the lead author of the study and a postdoc researcher at the University of Hawaii, Manoa School of Ocean, Earth Science and Technology, or SOAS. We expected some indicators of ocean acidification to be changing more rapidly below the surface because that was what some global studies had previously discovered. But we were very surprised that this was true for every single ocean acidification indicator. Knorr and co-authors analyzed a 35-year record of ocean carbon measurements made by the Hawaii Ocean Time Series program throughout the entire water column, from the surface to nearly 3 miles deep, almost 5 kilometers. At the open ocean field site some 60 miles north of Oahu, they found that in all layers, there are increases in carbon from natural decomposition of sinking organisms. In some layers, accelerated acidification is associated with fresher and colder waters. Deeper waters are already naturally quite acidic, and that's because of the biological pump therefore was just stated up here, the decomposition of sinking organisms that releases CO2 into the water in a soluble form, thereby making it reducing the pH. So quickly, since these deep waters are already naturally acidic to begin with, quickly increasing the acidity even more so can negatively impact planktonic species and other organisms that live below the surface. I've discussed with you before in relation to the CCD, the calcite compensation depth, or the lysocline, that's the layer where above it calcite can precipitate, where below it cannot, because the pH is too low and keeps it in solution. So in the long run, these changes in ocean chemistry make it harder for the ocean to keep taking up more CO2 from the atmosphere. In the past decade or so, there's been quite a lot of marine heat waves that can typically be brought on by unusual conditions in the ocean and atmosphere, and they're also tied into ENSO events. So researchers, fisheries managers, and other ecologically minded folks are concerned with the combined impacts of marine heat waves and ocean acidity events. Subsurface waters at Station Aloha are formed farther north in the Pacific. Changes in seawater properties impacted by evolving environmental conditions in other areas of the North Pacific are then transported by ocean currents into the deeper layers of the oceans around Hawaii. We illustrate that regional scale changes in source water chemistry and circulation are substantial drivers of the subsurface intensification of ocean acidification around Hawaii, said Christopher Sabine, who is a co-author on the study. So, regional scale changes in the water chemistry are substantial drivers of the subsurface intensification, along with circulation, of ocean acidification. So, what's the take-home message? Waters are getting more acidic. This study looked at the North Pacific, but this is globally for the oceans. The oceans are acidifying. And acidification, increasing acidification, is a major factor that can lead to mass extinction events in the marine ecosystems. So we'll just have to keep tabs on what their research continues to uncover. Thank you for your time.